Reacting mass and percentage yield assignment. Calculate the number of moles of material in the masses stated below, 0.0960 grams of H2SO4. Mass divided by molar mass of H2SO4, 98.1, 9.79 times 10 to the minus 4 moles. 1.48 grams of calcium hydroxide. Change into amount. Mass divided by molar mass, where the molar mass of calcium hydroxide is 74.1 equals 0.01997, rounded up to 3 sig fig 0.0200 moles. 2a, calculate the mass. Mass is moles times molar mass. 0.900 times 132.1 equals 119 grams of ammonium sulfate. Part B, calculate the mass given 0.0590 moles of silver nitrate. Silver nitrate has the molar mass of 169.9. Silver, 1 nitrogen and 3 oxygen atoms equals 10.0 grams to 3 sig fig, as asked for at the top of the paper. 3a, we got a reaction there between hexane and chlorine, which forms 2-chlorohexane. Calculate the amount moles of 2.45 grams of hexane. Molar mass of hexane is 86.0. Mass divided by molar mass gives 0.0285 moles of hexane. Calculate the maximum theoretical mass of chlorohexane that could be formed. The reaction is a 1-to-1 ratio between hexane and it to form 1 mole of C6H13Cl. So it's the same number of moles here and here, multiplied by 120.5, which is the molar mass of chlorohexane, equals 3.43 grams. Calculate the percentage yield, given that the actual mass is 0.564. The actual mass divided by theoretical mass times 100 equals the percentage yield, 0.564 divided by 3.43 grams times 100 equals 16.4% yield. Question 4a, 4.67 grams of sodium carbonate were added to an excess of HCl. The following reaction occurred. Calculate the amount of moles of sodium carbonate. Mass divided by molar mass equals moles, again, to 3 sig fig 0.0441 moles. Calculate the theoretical mass of sodium chloride. First of all, what's the molar ratio? So 1 to 2. So 1 mole of sodium carbonate forms 2 moles of sodium chloride. 2 times 0.0441 equals 0.0881. I use my whole calculator answer here to get the number of moles. Then we need to calculate the theoretical mass, which is the theoretical moles times by the molar mass, gives us 5.15 grams. We've then got to calculate the actual mass given the percentage yield of 95%, so this is slightly different to the questions you normally get. So we need to rearrange this percentage yield equation. Actual divided by theoretical times 100 equals percentage, as shown earlier. So if we rearrange that, the actual mass gives us is the percentage times by the theoretical divided by 100. So I've multiplied by theoretical, I divided by 100 to get to this place here. 95 times 5.15, which is our theoretical mass, divided by 100 gives us 4.90 grams. 5a, lead nitrate is heated. It decomposes to form 11.7 moles of gaseous mixture products, NO2 and O2. Now if you look at the equation, it's 4 moles of NO2 and 1 mole of O2. They are the gaseous products, the only gaseous products. The other product is PbO, which isn't solid. And there's 5 moles there. 4 plus 1 makes 5. In the experiment, however, there's 11.7 moles of gaseous mixture formed. Therefore, NO2 is 4/5 of that total mixture, because it's 4 and out of 5 is NO2, equals 9.36 moles. Then calculate the mass of NO2. Mass is moles times molar mass, which is 46. Gives us 431 grams. So in the question, we've got to calculate the maximum mass of zinc chloride that can be formed. So we've got to work out what the lowest number of moles is from the limiting reagent, the limiting factor. Calculate the number of moles of zinc oxide using the equation mass divided by molar mass gives 0.0437. It's a 1-to-1 ratio between zinc oxide and zinc chloride, so that's the number of moles that would be formed if the zinc oxide was the limiting factor. Use the equation, look at the 2-to-1 ratio of HCl to zinc chloride. So 0.0830, 2-to-1 gives 0.0415 moles of zinc chloride. This is the maximum number of moles of zinc chloride that can be formed. Some of the zinc oxide, because it's in excess, would remain unreacted. HCl is called the limiting reagent. So now we'll calculate the mass of zinc chloride, moles times molar mass, gives 5.66 grams. In the next question, we've got to determine the symbol, mass number and atomic number from the original element of nitrogen. So, best thing to do here is to work out the number of neutrons, protons and electrons for nitrogen 14(7). We're then told that there are 3 fewer neutrons, there are 2 fewer protons, 5 plus 4 makes 9. That gives us the overall symbol of the element. Configuration of N3- and N, well, N is 1s2, 2s2, 2p3. 3- means add electrons to the outer shell, so we're adding 3 electrons to the 2p3, making 1s2, 2s2 and 2p6. So we start with the element silicon, mass number 28. Look on the periodic table, it has 14 protons. Calculate the number of neutrons and protons, that's 14 each. 28 take 14 gives 14. Atomic number is the proton number. The other element has 6 fewer neutrons, so 14 takes 6 equals 8. It has half as many protons, so 14 divided by 2 gives us 7. 7 plus 8 gives us 15 for the mass number and 7 for the proton number. RAM calculation, 10D, chromium, 4 peaks. Relative abundance times by m over z divided by the total of the relative abundances. There are the calculations: 4.3 times 50, 83.8 times 52, 9.5 times 53, 2.4 times 54, divided by 100 gives 52.1 to 1 dp as asked for in the question.